welcome back. So we are done now solving for this master question, which was question number 1, which is algebra. Now let's look into functions. So that we can be happy as well. Let's now look into functions. So functions will be plus or minus 35 marks in your test, which you'll be writing. Let's look at the solution for that. So what are we given them? Let's go. So initially we are given p of x. Okay, question 4. Let's write it down. Question 4. So on question 4 we are given p of x. So p of x 4.1, we're given p of x to be equal to 1 over 3 to the power of x. Oh, great. Is p an increasing or decreasing function? Definitely that's a decreasing function because of the value of a. So 4.1.1, that's a decreasing function. Okay, that's a decreasing function. You can also prove this by plotting this. When you're plotting this, it's going to be something like this. You plot this with your calculator, then everything else should be fine. So please, the value of a is not greater than 1, so definitely this is a decreasing function. Now let's proceed. Now on 4.1.2, what do they ask? What do they want? 4.1.2, they are saying determine p inverse, the inverse of p. Wow. So we know that p of x is equal to 1 over 3 of x to the power x is the same as y. So now we have y equal to 1 over 3 to the x. The first rule which we apply when we want to determine the inverse function is that we invert, or um, we transpose, we exchange. So where there is y, we'll put x 1 over 3 to the power of y. Then we solve for y. Now we apply the log, then we have equal to y. So then therefore p inverse is equal to log base 1 over 3 times x. Now determine the domain of p inverse. Wow, come on guys. So we know p inverse of x is going to be the inverse of this function. So the original function, the domain of the original function was x is the element of real numbers, and the range was y must be greater than 0. So which means this is for p of x, so which means p inverse of x will be equal to the domain of this function will be x greater than 0, then the range will be y, element of real numbers, because the domain of the original function is the range of the inverse function, and the range of the original function is the domain of the inverse function. So here it's going to be x greater than 0, just like that. Now they say write down the equation of the asymptote of p of x minus 5. So now we have p of x minus 5, which is the same as, so initially we have p of x, which is equal to 1 over 3 to the power of x. So p of x minus 5 is the same as 1 over 3 to the power of x minus 5. So which means this is going to be our horizontal asymptote. So therefore we can write the equation of asymptote to be y equal to negative 5. Now let's proceed. You can see that we are rushing because this is easy, guys, if you follow us properly. Let's look at that question 4.2. 4.2, we are given f of x equal to 4 over x minus 1 plus 2. What is this? This is a hyperbolic function. So what do we know about the hyperbola? By now we know that it has a vertical and a horizontal asymptote. So with that being said, now we can definitely see that, oh, okay, since it has the horizontal and the vertical asymptote, we can solve this thing fast. The first question, of course, they asked 4.2.1. Write down the equation of the asymptote of f. Of course, x is equal to 1 and y is equal to 2. Those are the two asymptotes of f. This one is the vertical asymptote and this one is the horizontal asymptote. Now let's look at 4.2.2. They are saying calculate the x-intercept. Oh my god. We know that x-intercept, we let y to be equal to 0. So if y is equal to 0, what does that mean? It means that 0 is equal to 4 over x minus 1 plus 2. Let's go. Negative 2 is equal to 4 over x minus 1. Let's solve for x. Let's solve for x. We cross multiply. Then now we have negative 2x plus 2 is equal to 4. Now we have negative 2x is equal to 2. Divide by negative 2. Divide by negative 2. Then your x is equal to negative 1. Then you write it in a coordinate form because you understand that the x-intercept is a point where the value of y is equal to 0. So you write it negative 1 is to 0. Then after that, you are good to go. Now let's look at 4.2.3. 4.2.3. They say sketch the function of f. In order for us to sketch, we must have the y-intercept as well. So let's just say it y-intercept. We let the value of x to be 0, so y will be equal to 4 over 0 minus 1 plus 2. Then our y will be equal to 4 divided by negative 1, that's negative 4. Negative 4 plus 2, that's negative 2. Then again, we write it in a coordinate form. 0 is to negative 2. Then after that, they're saying sketch it. Let's sketch this thing. Let's sketch this function because we are happy. We have everything we need. We know that our horizontal asymptote is x. So it's y equal to, where is it? Y is equal to 2. So where is 2? 2 is somewhere here. Then we plot it. Let's go. So y is equal to 2. Then we have what is our vertical asymptote at x is equal to 1. Let's go. Then now our x-intercept, it's negative 1 is to 0. So negative 1 is to 0. Here it is. Then we have 0 is to negative 2, which is our y-intercept. Then after that, let's plot this function. So of course, your graph cannot touch the asymptotes. Okay, mine is a bit ugly. Let's try it again. Here we go. Okay. Yeah, it's not that bad. But yours, please make sure that it's more beautiful than this. Okay. This can't be like this. This should be a curve. Should be a curve, something like this. So this will be our function. Okay, this will be our function. Then we are happy with that. Now they are saying use the graph to determine the values of x for which 4 over x minus 1 greater than negative 2. Guys, do you see they're trying to confuse us? Why? Because they are just saying that 4 over x minus 1 should be greater or equal to negative 2. So in other words, just look at this in this perspective. They are saying that where 4 over x minus 1 plus 2 is greater or equal to 0. So we can see that this is our function which we're dealing with, and this is the y-intercept. So this is the y-x-intercept, because we can see that the y value is equal to 0 when we are looking at the perspective of a critical values. So we can check on our functions. Where is the function greater or equal to 0? We can see that this function is greater or equal to 0 when x is greater or equal to let's see, where is our function greater or equal to 0. See that x value negative 1, negative 1, 0 and above. Yes, so it should be x greater or equal to negative 1. Should be x greater or equal to negative 1. Let's see. Yes, it should be x greater or equal to negative 1. So that it can make sense. Now we can proceed now. Let's look at this question first. So what do we have here? They say determine the equation of the axis of symmetry of. We know that in a hyperbola, how do we determine the equation of the axis of symmetry of a function? So this is quite easy, because an axis of a symmetry of a function of a hyperbola is either always this. Let's say this is our original function. For the positive gradient, it's always y equal to x plus p plus q. For the negative gradient, it will be y equal to negative x plus p plus q. So let's apply the same concept, but in this instance we know that we have 4.2.3. we are given initially that, let's look at this, f of x is equal to 4 over x minus 1 plus 2. Now they are saying that it's f of x minus 2. x minus 2. So this will be 4 over, where there is x, we substitute with x minus 2 minus 1 plus 2. So this will be 4 over x minus 3 plus 2. So this is the new function. So for the negative gradient, then definitely this will be our axis of symmetry. So y is equal to negative of x minus 3 plus 2. This is negative x plus 3 plus 2. Then we have y equal to negative x plus 5. Then after that, we are happy. Happy, 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 happy. If you're happy and you know, nod your head. If you're happy and you know, clap your hands. So we are happy. We have all those 18 marks in the bag. Oh my word. It's so easy to pass paper one. Let's pass paper one when we are writing in our time. Now let's look at this last question on function, which is question number 5. Let's look at question number 5. Okay, question number 5. The graphs of the functions f of x is equal to negative x plus 3 squared plus 4 and g of x are drawn below. We can see that those are the function. The parabola function is f of x and g of x is our straight line function. So we can see that, oh, okay, this is great because point A and point B is the point of intersection of both f of x as well as g of x. The moment we were able to analyze that, that's the moment our lives just went so easy for us. Now they are saying in this question, determine the coordinates of the turning point, and the turning point of this graph is this point here. It's this point here. This is the turning point of this function. So they're saying that determine the coordinates of the turning point, and what they gave us f of x to be equal to this. So we know that this is called the turning point formula when we are looking at the perspective of the different types of or the different standards of parabolas. We have the turning point formula, we have the standard formula, and we have the turning point formula, and the x-intercept formula. So since we are given f of x is equal to negative x plus 3 all squared plus 4, then the turning point is going to be negative 3 is to 4. Definitely we know where we get it. This is the turning point value. So if it was negative here, it was going to be positive here, but since it's positive, it's going to be negative. That's how we apply our turning point. Now they say that in the next question, where is it? Here we are. Write down the range of f. This is easy because we know that the range of a parabola is always y element of real numbers, where y should be less or equal to the value of the turning point. When it's like this, which means that we're starting from negative infinity and we end here on the y value of the function. So this is saying y must be less or equal to 4, or someone can say y is the element from negative infinity to 4, then you put a square bracket to show that it's an included side. Now let's look at 5.3. Show that the x coordinates of a and B are negative 5 and negative 2 respectively. We can see that A and B is the point of intersection of these two functions. So this is already easy. So in other words, they're saying that determine f of x equal to g of x. So they gave us negative x plus 3 squared plus 4 is equal to, what is our g of x? Our g of x is x plus 5. So this will be x plus 5. Then let's break this thing down. Let's break it down. Let's neutralize this thing. So how can we neutralize this thing and get the correct values which we want to get? How can we do that? Guys, talk to me in the chat. Please talk to me. I'm here. I want to hear your opinions. Negative, this will be x squared plus 6x plus 9, of course, plus 4 equal to x plus 5. This would be negative x squared minus 6x minus 9 plus 4 equal to x plus 5. This should be negative x squared minus 7x. Then negative 9 plus 4. Negative 9 plus 4, that's negative 5. Negative 5 minus 5, that's negative 10 equal to 0. Then we divide all through by negative. Then we get x squared plus 7x plus 10 equal to 0. Then after that, we can see that, oh, what is the value which we are looking at there? Then after that, we look for the factors so that we can get the correct value, of course. XX. If you don't know how to use the factor format, use the bus, use the quadratic formula. It's always there to save your day. So this will be XX. Of course, we want 10. Definitely we should have 5. We also have to have 2. How can we get 7? Sure, this should be positive, this should be negative, right? Yes, but how can we get negative 10 at the end? Let's see. Let's use our formula. Let's see something where we did a mistake. Let's see. Let's see so that we can always see that it's easy for you to make few mistakes. But I want to double check, where did we make the mistake? Let's check that out. So we said we have negative x squared minus 6x minus 9, of course, plus 4 equal to x plus 5. So this should be negative 7x, of course. Then we have negative 9 plus 4 minus 5. That's negative 9 plus 4 minus 5. That's negative 10. Okay, then we divide everything by negative. That's x squared plus 7x plus 10. Now let's look for the factors. Let's see if I did something wrong there. Negative 7 plus square root 7 squared minus 4ac divided by 2a. Then we get, so this one should be positive, and this one is supposed to be, let's see. Thank you so much. You see, if sometimes you see mistakes, make sure that you fix your mistakes. Okay, so we can see that these two must be positive so that we can get 5 plus 2, it's 7. And after that, you can fix that mess error, because I thought that it's 5 and 7. So that was the mistake which I have. You don't do mistakes in the test. Make sure that you make it a point that you S everything. So x will be equal to negative 5, or x is equal to negative 2, which basically they have already asked us to prove that this one is negative 5 and 2. So you can even say that then x is equal to negative 5, this is xa, then other one xb equal to negative 2. Then after that, we are happy. If you are happy and solve this maths. Okay, great. Now on 5.4, hence, which means use what you just calculated. The moment you say the word hence, which means use what you just calculated. Determine the value of c for which the equation negative x plus c plus 3 squared plus 4 equal to that plus 5 has one negative and one positive root. What do we see from that? We can see one thing which I've already noticed right now. We have seen that this graph has been shifted to the right. Okay, it has been shifted. F of x has been shifted to the right, because we know that the moment it's x plus something, which means the function has been shifted to the right. Okay, always when it's x plus something, which means it has been shifted to the right, to the left. So when it's positive, it has been shifted to the left, and when it's negative, it has been shifted to the right. So how can we counteract that part? How can we solve that part? Now they want one positive root and one negative root. Where can we find that? That's already easy. If you know that this graph has been shifted to the left, which means it should be between negative 5 and negative 2. The value of c must be between the two. Now the maximum distance between f and g in the interval of that, if, let's maximize the screen. Yes, what is the maximum distance between f and g in the interval xa and okay, and all right, great. So they are saying that h of x is equal to g of x plus k, and this k value is the maximum distance between f of x as well as g of x. So how can we solve this? We can solve this in an easy way, because in order for us to solve this, we just have to say f of x minus g of x. Okay, then this should be negative of x plus 3 squared plus 4 minus g of x, which is x plus 5. This is the negative of x squared plus 6x plus 9 minus or plus 4 minus x plus 5. Then this should be negative x squared plus minus 6x. Let's rectify that. Minus 6x minus 9 plus 4 minus x minus 5. Then we have negative x squared minus 7x minus 10. Okay, then now we want to know the value at maximum. Oh, I'm sorry, I forgot to do this. So we know that at maximum, we know already that at maximum, so this is how we do f of x minus g of x, so that we can find the distance, the maximum distance between f and g. Then after that, we subtracted the two functions. This is f of x, this is g of x. Then we subtracted both of them. Then after that, we are here. Now we know that at maximum, we must find the derivative. So this will be negative 2x minus 7 at maximum. And let's calculate the value. So we say at maximum, negative 2x minus 7 is always equal to 0. Then x will be 7 over negative 2. Then after that, we substitute this x value so that we can get this distance here, because we say that this distance AB, which is also the same as k, is the maximum distance. So substituting this value, where is my calculator? Then that should be negative 7 over 2 all squared minus 7 times negative 7 over 2 minus 10. Then we get our answer there. Let's see. Minus 10 squared 10. Then I'm getting 26.75. Please, if you see any mistake, I doubt if I did any mistake. No, I didn't. But please make sure that you use your calculator correctly, as I just did. Okay, so this should be 26.75 according to my calculator. Then after that, we can now know that, oh, h of x is equal to x plus 5. Then what was our h of x again? Our h of x, our k is now plus 26.75. Then this should be x plus 5. No, let's say 5 plus 26. Then we get 31.75. So this should be the equation which we'll be playing around with. Let's check something. Yes. Then after that, you are done with functions. Yeah, I hope you had nice time with me. Have a great day ahead and continue practicing. Ask us questions. We are here to assist you. Have a great day ahead and see you guys tomorrow. If you have more questions, just ask us so that we can solve them. We will later do calculus, which is important. So number patterns, they were easy, so there's no need for us to do them. But if you want us to go through them, just tell us so that we can do them for you guys. Without wasting much time, have a great day.